Okay. Okay. Hello everyone. So my name is Tamal. So today I will go through some basics of the hacking session that we'll conduct this semester. We'll mainly be working on the backgrounds for binary hacking. So these are like I think for the first two sessions, it will be a little bit more lectures like to build the background. After that, it will be mainly hands-on. Everyone of us will do actual hacking here, binary hacking here. So this is just to give you some idea. What do you want to, what do you need to know for this one? Okay. So uh, the session that will be held here for the hacking session will be online on this channel. And also Dr. Zhao has a lot of videos on binary hacking on there. So you guys can take a look. And for every day after the session, the videos will also be uploaded to this channel. Okay. Okay. So the topics for this semester are mainly we'll be doing attacks, binary hackings for x86 and 32-bit and also 64-bit platforms. We will look at some vulnerabilities that exist. Vulnerabilities can be software vulnerabilities or also can be hardware vulnerabilities. And we'll develop some exploits to leverage those vulnerabilities there to do some tasks that we want as an attacker. Okay, so specifically we'll do software stack-based buffer overflow attacks, shellcode development, format strings, heap-based buffer overflows, integer overflows, and ROP attacks. So today, we'll be mainly talking about some backgrounds, such as for compilers, we'll know about linkers, loaders, x86 architecture, and the instruction set for that one, and some basic reverse engineering tool, and we'll be using the tool called GDB for that one. So we will see how to use GDB to debug a program and how to reverse engineer a binary. And we will also look into the Linux file permissions, and lastly, the C2ID programs. Okay. So the background for this hacking sessions are mainly one background is knowing the C. If you know C good enough, I think it's okay. It's like you have enough background to conduct these sessions. And other classes that might help you are the programming class or the operating system class. So even if you don't took did you already take these classes, I think it's okay. If you know C, it should be fine. And and if you need more knowledge about C, you can read this book, the classic book on C, and other skills such as reverse engineering, object dump, IDA Pro, Githra. These tools we will learn in these sessions how to use these tools, and we need to if you don't know something, just Google it and like read some online materials to know about some instructions or some architectures, things like that. Okay. Okay, so some related books. So this book, Practical Binary Analysis, is very related to these hacking sessions. So it's actually some of the chapters are more advanced than we will conduct than the session that we'll conduct this semester. So maybe if you want, you can take a look in this book. And also these are some very popular, very well-known papers that you can look into to get some more deep knowledge on these things. So first thing is I think Dr. Praja already shared the link of this platform. So this is the hacking environment we will be using. So you don't need to set up anything in your local machine, like no virtual box or anything. We will just use this platform. So first task of us, everyone here, is to create an account on this platform. And you will need to use the UB email. So it's only accessible to the UB students. And if you are not on campus, you need to use the VPN to access this website. So everyone now should, if you already, did you guys create the account there? Okay, so then we can move forward. Okay. Okay. So for the hacking environment, the server, the website that we will be using, it's Intel. and we'll be using the Linux Ubuntu there, and some other tools like PwnGDB, Pwn tools. These are, we'll go through these tools together in these sessions for maybe not all, not all today. Step by step, we'll go through those tools. Okay. Okay, so first background knowledge is on the compiler, linkers and the loader, linker and the loader. So when we write an application, we usually write it in a high level language, right? Like C, C++, Java, things like that. So that application needs to be converted to a machine instructions at the end, right? So this step, the compilation from the high level language to the machine instruction, it depends on which language are you using, right? Like for Python, for Java, for C, this is different. So for us, in this session, we'll be in the hacking this semester at least, we'll be mainly working on C programs. So the environment we are concerned here is about is Ubuntu system, and the compiler will be using GCC. Okay, so from the start, when you write a C program, there are five main steps to get a program running on your computer. Four of them, these first four are actually the compilation step, and the last one is the loading, just running a application. So we'll look into everyone in detail. So first one is the pre-processing step. So as the name suggests, it's a pre-processing step on your source code, right? So what is done in this step? So things like removing the comments, we write comments in the source code, right? But in the machine instructions, those are actually not there. So some things like that, like removing the comments, it's expanding the macros. These things will happen in the pre-processing step. And we will see real examples on the platform later. So this is just to give you an overview of the compilation step at first. So the output of this pre-processing step is still a source code, like text file. The extension is .i. So it's still in human readable form, not like assembly or machine code. So we got the .i file from the pre-processing. Then from there we go to the compilation step. So in the compilation step, the input is the previous output from the .i files in this one. So from the output is the assembly code. So do you guys know about the assembly? Do you guys have some experience on assembly code, right? Even if you don't have like much experience in assembly code, it's okay. We'll actually learn those things in the hacking session too. Okay. So, but this assembly code is actually this is also human readable, right? Assembly code is human readable form. It's not, but yeah, but but still you can figure out things here. Okay, so okay, so this assembly code is architecture specific. For example, we have new Macs, right? M1 Macs, M2 Macs, right? So those are ARM based. So the assembly code for ARM and for Intel will not be the same. It depends on the architecture. So every architecture have different instructions, right? So this code, the .s file, will be different. Depends on which platform you are trying to compile. If you are compiling for Intel machine or AMD machine, it will be different from the M1 Max or M2 Max, right? So the output of this one is the .s file. Then we have the assembly step. So the assembly in the assembly step, then we are actually getting towards the end. So we get a binary file on this step. So the extension for this one is the .o file. These are called the object files. Yeah, and yeah. Okay, so these are the object files are already in machine instruction, already in machine code, but it's still not an executable file. So when we usually run a GCC command through the terminal, we get a one file, right? One executable file. So we're not there yet. So to get that file, we have the linking stage. This is the last stage for compilation. So when you like develop application, you will have multiple files, right? Your project will have multiple files. So each file will have its own object file, but they are not linked together yet to get the executable file. Okay. So and apart from different object files, you can use a lot of libraries, right? Those are not also linked together yet. And other things like symbol tables, relocation entries, those things are also there. We need to link all them together to get a final executable, right? So those things are done by the linking stage. So the linker knows those information, and it links all of them together to give us a final executable file. Okay, so these are the compilation files. So the output is there. We are finally got the executable file, the binary file, right? But this file is just sitting in your hard disk, right? It's not a process. It's not running. It's just a file in your hard disk. But we need to load this to memory and start execution of the program, right? It's not a process yet. It's just a file. So that part is done by the loader. Loader is the part of the kernel, Linux kernel. That loader loads this your program from this hard disk to your main memory, right? And apart from not only this, it does some other tasks too. For example, checking the permission of the file, if the file actually has the permission to run on your machine or not, right? Things like that. So that part is done by the loader. And finally, when it's loaded into memory, it gives execution to the program. So then the program can start executing. Now we have a process that's running on your computer, right? Okay. Okay. So do you guys have any questions about this one? Yeah.
Where can we find the lecture slide?
Sorry.
Where can we find the slide?
Lecture slide.
Do you plan to slides?
Yeah, we can share.
Okay, yeah, we'll share the slides after the session. Okay. Okay, so now we'll look at the example of the things we learned from this slide. Each step we'll look at example of this one. So this program has 3 files. One is main.c, add.c file, and there is a header file for the add one, right? So in the main.c file, we check, it takes several arguments. It checks if it's 3, like the argument is 3 or not. So when you run a program in C, there is by default one argument is the program name. Okay. So for example, here if the program name here is add32, the first argument will be this one, this name. It's not like user provided. So here it checks for 3. That means this program can take 2 arguments. One is by default, right? So it can take 2 more arguments. So this program requires 3 arguments. And here you can see 3, but actually it's 2. One is the file name, right? So it takes the argument, it prints the usage. Usage is just adding 2 integers with 50. Then we convert it to an integer. This is string. These are strings, right? This is a char pointer. We convert into this apply function to an integer. Then we call this add function. So add the add function just adds those 2 numbers and with a base like 50. Okay. So now if we go to the platform, so everyone can follow with me here. So you can do this step by yourself too. So if you go to the challenges, then add 32. So yeah, this is how so for this hacking session, the platform works like this. For any challenge, for example, if you want to work, if we want to work in a ROP challenge like this, so we'll go to this challenge button first, then we'll run the program. This is run challenge. We'll run the challenge. So it's running now. Now we go back to the terminal. So we have a terminal here that is running your challenge. So this is the same step that we will follow for every challenge or every task in this session. Okay. So now we'll look at the add challenge one. Okay. Okay. So if you are in this directory, you will see there is a code folder, right? Just go inside the code folder. Okay, so there is a inside there is the add. Go inside the add. Okay. So now the maybe I can pause here for a few minutes so everyone can get to this stage. Yeah, yeah, you're yeah, okay, okay. Yeah.
Yes. Maybe you need to register again. Yeah, I don't know. Maybe you can walk around to make sure.
Yeah. You cannot register? Just register a new account with your username.
You don't have to use.
Yeah, you have to use
They have to use.
Yes, you have to use.
You have that.
Yeah, I
configured?
configured it like that.
Okay.
We can change that from yeah, it's okay, right?
Yeah.
Okay, so I think everyone is in the same page. So now, so if we when we compile a program, like if you compile here, it should be like this one, right? So it will give us a executable file out, right? But we don't see the intermediate steps, right? The ones we saw in the slides. We don't see the .i, .s, .o files, right? So for to do this one, you need to tell GCC that to output those intermediate files, right? So we already have a make file in there, so we don't need to write it on our own. So we need to provide this safe temps flag to GCC. So this is just to tell GCC that output the intermediate files. Okay. So if we just run make here, you will see we have the for each file. See, so there was two C files, one add and one was the main.c file, right? So see, we have two object files, add.o and main.o, and also we have the intermediate files like add.i after the pre-processing step. For example, after the pre-processing step, we should have a .i file, right? So if we look at the directory now, we have the .i file for add and .i file for main. So yes, I'll show later. So these are the intermediate files for this step. Then if we map it to this file, we should have some assembly files too, right? So if we go back, you will see we have a assembly file for add, assembly file for main, things like that, right? So now, as I said that we maybe we can see some what like for example, what the pre-processing step does. So if we get the add.i file, okay, so let's look at the difference first. Okay, so this was the add function in the source code level, right? We wrote specifically in this line, we wrote return a plus b plus base, right? So base was defined as 50 in the upper strings. So now after the pre-processing step, you can say that it's replaced by 50. In the pre-processing step, we will do like expand the macros, right? This is a macro. This is a macro 50, right? So after the pre-processing step, this base will be replaced by 50, right? Okay, so if we like check the main.i file too, see there are a lot of things that compiler added because some things are from the library, so because it needs a library, right? This is a library. Some things are added from the library file, so it's added here. So we can check the other files too, like the assembly file, add.is. Yeah, so these are the assembly instructions that we have. So, okay. And the object files, so it's not human readable. These are already binary files, right? And our actual output is this file, at_32. This is the executable file, right? Now we can just like execute the program. We'll have a output, right? So this is what the program was supposed to do. It will add two numbers and add 50 to that. It will give you this one, right? Yeah, so this is how actually one more thing is that this is how we run the program in Linux in command line, like / the program name and the arguments that we want. So it requires two more arguments, right? So the arguments are like space separated. So 4 and 8. So this is how we run the program in Linux. Yeah, so everyone should go to try to run the program by themselves. Yeah, if it's done, we can move forward. You're done? Okay. 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 Run the program? You run the program? Yeah, just run the program and because we leave those things later, right? Yeah. Let's just go to code. Yeah, do an array for. So there's a code folder. Go inside it. There's a folder there. No, there's a X folder. Let's go CDN. So run main. So it has a file, but you need to compile it. Just make or as. So we see the other files there and we see the but you need to give two numbers. Because two are done?
So Eric, you already did this, right? So since you already did this, you can do over the wire. This you do over the wire. Which one? You have to go on that's working on it.
Okay, so okay, so now we will see some x86 architecture background, the things we will need to know for the binary hacking. Okay, so first is the data types. So this is the main 5 we actually need to remember. But if you encounter something new, we can just find out online, right? So the bytes are 1 byte is 8 bits long, word is 16 bits, double word or D word is 32, quad word is 64, and double quad word is 128 bits. Okay. So now Indianness. So Indianness is a concept of like byte ordering in your architecture. So there are two main Indianness. One is Little Indian. Example of this one is Intel or ARM. One is Big Indian. So in Little Indian, least significant byte has the highest or lowest address, and for Big Indian, the least significant byte has the highest address. So we'll see an example of this one. if you consider memory like this, where address 0 contains 12, address 1, 34 hex, these are hex values. Address 2 has 56 and 78. So it's increasing in this order. So for if we consider we have a little endianness, so it says that least significant byte should be in the lowest address, right? So now if we access the double word, means 4 bytes. Double word is 32, right? So it's 4 bytes. So and we consider each one is 1 byte, right? So this will be the value, right? Because least significant byte should be in the lowest address. So here is lowest address is here 0, right? So it should go to the least significant byte here 12, and then from there we move to the higher address. Then it will be 34, 56, and 78, right? So in the big Indian one, same thing will be in the reverse order. So depending on the Indianness, if we access the memory 0, the value will be different, because the Indianness is different in different architectures, right? So any questions on this one? Yeah.
What makes a byte more or less significant?
So
Significant here.
it's a position, not yeah.
Let's say.
Yeah.
You have a number. Okay.
Yeah, position, not the value. Yeah, and the position. So 12 is in the least significant position. Okay. Okay, so move forward with this one. Okay, so base registers. So there are a lot of registers in x86. So some of the base registers, like 8 or 9 registers that we need to know. Other things for now we don't need to worry about. Maybe if we move forward, and then maybe we need to know those things. But mainly for now, we need to know the 8 general 32-bit general purpose registers, and there is a 1 E flag register, and there is a program counter or EIP, and other some special purpose registers. So we'll look at some structures here. So these are the general purpose 8 general purpose registers in x86. We have EX, EBX, and so on. So these are the 8 general purpose one. So inside, for the first 4, inside, so this is 32-bit. EX is 32-bit register, but they can be accessed through like 16-bit and 8-bit. For example, here H is 8 bits. So we can just access this portion of the register. L is 8 bits, but in the lower. H means high, L means low here. So we can access this portion of the register too. Same for EBX, ECX, or EDX. And last 2 ones, ESP and EBP. So it's related to stack. So if you don't know like what stack is, you can consider it like a special memory segment, special memory range that your program will use to store data, store parameters, things like that. So so when your program executes, so it will continue to put the local variables, right? A function can have some if when you define a function, you define some local variables inside that function, right? Those variables will go into the stack, right? But when it executes, so it will keep growing, right? It can keep increasing or decrease, right? So we need to keep track where your stack is right now. So ESP is for that purpose. So ESP points to stack pointer, like right now, where is your stack? Yes. And EBP will always point to the start of your stack. Like when for your function, this is the start of my stack, and somewhere else, but it will keep increasing, right? Increasing or keep changing, not increasing. It will keep changing. So ESP will keep track of those things, and EBP will always point to the fixed position for you for one specific function, right? It will always point to the start of your stack. Okay. And there are two other registers, ESI and EDI. So those are ECI and ESI and EDI are like source and destination index registers for array and string operations. So we can talk about this later in detail. Okay. Okay. So these are we already talked about this one. There is a E flag register. So uh, the operations we did like add in source code, right? So this will be converted to add instruction in assembly, right? So when we add two numbers, when you do the add by yourselves, when you learn adding two numbers, right? When you add, it can have a carry, right? Those carry, so those things are indicated by this E flag register. For example, it has a CF flag to indicate that this addition has a carry. It can have a zero flag, right? So these things like that are stored in this E flags register. Okay. So lastly, we have the instruction pointer. So the instruction pointer, it returns to the it holds the address of the next instruction to be executed. Like if you ever used a debugger, so when you debug a program, right, there is an indicator that this line will be executed next, right? Same concept. If you go to a lower level, this register will, when you debug a assembly, debug a binary file, this register will indicate which instruction will be executed next. Okay. So these are the all of the registers in x86. We don't need to worry about those for now. Mainly those registers that we talked about. The other registers we don't need to worry about that now. Okay. So some instructions. So this is the in x86. This is the general form of instructions. We have a this part is optional. The level we might have a level or not, but we will have a mnemonic. We have operands. So here it's shown three operands, but it's not necessary that an instruction have to have three operands. It can have 0, 1, 2, 3. The max limit is 3, but it can have no operands too. Okay. And these operands can be immediate values like a value, direct value, a register, or a memory address, right? So we will see some examples how those instructions work. Okay, so source and destination. So for example, if we write A is equal to B plus C, right? Here source are B and C, and and the destination is A, right? So same here in the assembly, there will be some source and there will be some destinations. The assignments that will go is the destination registers, right? Okay, so some instructions here, like hold instruction. So it holds the CPU until the next interrupt. For example, the inc instruction, inc increases the operand by 1, adds 2 operands. IML, for example, multiplies 2 values, right? So instead of uh, looking at all the instructions like this one, we can use GDB to learn how those instructions actually work, right? So now we go back to the platform. We are already here, right? We have the binary at the 32, right? Now we want to use GDB to debug the program and learn how each instruction works, right? So this is to use GDB, we need to run it like this: gdb./ the file. So everyone should do this step. This is just to show how GDB works, and we will also learn how each instruction is executed. Okay, so everyone should run the GDB now. / GDB and / the program name. GDB? Oh, you're doing it? Yeah. Okay. You run the GDB? Okay, nice. Okay, so after GDB, first we need to set a breakpoint somewhere. So the program stops there. So let's set a breakpoint. So to set a breakpoint, we just type B. B means break and the function name that we want to break. So type just B main. It will set a breakpoint at the start of the main function. Okay. Okay, so we saw that before that this program it needs two arguments, right? So this is how to provide arguments in GDB. R stands for run, so it will run the program, and after that the arguments is separated. So if you type this, so it takes these arguments and the program halts at the main function. Okay, to see the disassembly instructions, we can do dis. Just type dis. Dis stands for disassembly. So it will show you the disassembly code of your main function. Uh-oh. Sorry? Zooming. Okay, let me.
Terminal, the terminal.
Yeah, let me do that.
You're using Chrome just to control plus. Control plus. That's I mean. Yeah.
Okay. Okay. Okay, to GDB. Okay. Then we set a breakpoint at main. Then we run the program. Okay, so we are here. We do disassembly.
Dim the light here.
So if you do this, if you type the disass command, it will disassemble. This is disassemble your main function, and this arrow indicates your current execution is here. EIP is here, right? So now let's pick a simple instruction first. For example, the add instruction here. No, maybe something a big value. Yeah, for example, this one. We want to see like how this instruction executes. So first what we do, we set a breakpoint there. We copy the address. We just set a breakpoint there like this. B asterisk and the address. Okay. Sorry. Yeah. So for you, we want to see how this instruction executes, right? So we want to stop here. We want our program to finish executing until this point, but we want to stop it here, right? So the address for this instruction is this one. These are the addresses in the left hand side. So we set a breakpoint there. So we copy the address from there and we do like B asterisk then the address. Okay. Okay, so after setting the breakpoint, we need to type C to continue or like to get to that point first. Then we can see the disassembly. So if you do separately now, we can you see that the program stop. Okay. Then we can move next. Okay, so now we want to see like how the add instruction works, right? So we can see from the instruction that it's adding some value to the EBX register, right? So first we check what is the content of EBX right now. So if we type P by X, then EBX. So this is the value in EBX at this point. Okay. So if we check the instruction, it's adding this value to EBX, right? So if we add this one, this is the value. Now if we check, so at this point, if you like with graphical user interface, when we can step over, right, in debugger. So same thing if you want to do in disassembly to type step in, or like you type can just NI to go to the next instruction, execute the next instruction. So if we check now, see this it moved one step forward. So it already executed this instruction, right? You understand? Okay. So the result, so this instruction, what this one does, it adds the content of EBX with this value and stores the result in EBX itself, right? So if the instruction executes correctly, the value should be this value, right? Because the addition of this one results this one, right? So if we check the content of EBX now, is the same value, right? So this is how we can like verify like how each instruction works, or we can, if you want to know at runtime, understand the instruction, we can see it like this. If we don't understand some instruction, we can also debug like this to find out how each instruction works. Okay, so maybe we can see one more example. For example, which one? Maybe the move one. Yeah, we can see the move one. So similarly, we set a breakpoint there, continue to that point. So we are here now. Now it's moving EBX, the EBX plus 4 to EDI, right? So if we check the content here, what was the instruction? Instruction is ECX, right? ECX. ECX is this value and EDI. Okay. EYX sign EDI. EDI currently is this value. So after this instruction executes, EDI should change to this value at EAX plus 4, right? Okay, we don't need this one here. Oh, sorry. So P means print, /x means in print in hexadecimal format. So if we just print it instead of X, if we just remove this one, it will just print in decimal. X means that print in hexadecimal format, right? X by X. X by X means examine the address. Examine means the your register can hold the address of a memory, right? So if you want to know that what is the value at that memory, you can do X by X to check what is the value in that memory. Okay. Or yeah, maybe we will know like other stuff from GDB later as we go on for the next weeks. We'll know more about GDB. Okay, so this is the instruction. This is the instructions. So there are a lot of instructions here in the slides. I guess we can skip this one. You can take a look how instruction works, but generally, like if we don't know, like encounter instructions that we don't know how works, we actually just Google it, try to understand what the instruction does. Okay. So data movement instructions is the move. So move can be registered to register or registered to memory, things like that. So you can take a look here. Okay, maybe Elia, maybe we can skip for now. Okay, instructions we can skip. Yeah, so okay. Yeah, we can take a look at this one. So there is a if we this function, if we take a look at this function, it's actually still what was the purpose of this? Okay, so this is to see the difference between when you compile for different architectures for 32-bit and for 64-bit. Here we are talking about these things, but if you compile it for ARM, it may be different, right? So here's the source code of the program. It checks for the arguments, it means the size of long, then it converts the arguments to a long value, and it just calls this a long add function to add those values together, right? So if we go to the challenges folder, there is the challenge is added here. It's L at 32. So if we run the challenge, okay. So okay, another tool we will be using is object dump in this course. So this is how to use object dump. Just do object dump, object dump, right? Yes. Okay. Okay. The P
minus D minus N.
okay. So this is just to dump the disassembly code of your target. So this is how to use the tool. We type the tool name object dump, minus D stands for disassembly. So it disassembles your program. And the output of this one is it will disassemble every function present in your binary. So here we'll take a look at the add function. So these are different. Okay, so this is the 32-bit version implementation of this function. This function just does nothing actually, just adds these two numbers together. So we have a slide also to show you the difference. So you can see for different versions, the generated assembly is different for 32-bit and for the 64-bit, right? So there are different reasons for this different disassembly depending on stack layout, parameter parameter calling procedure. So we'll not go into those details right away. We'll go take a look on those things later in this session. So this is just to show you the difference, right? Okay. Okay. Next we do Linux file permissions. So okay. So in Linux, we have a owner. Owner. So owner is just the user who created a file, is the owner of that file. So so by default, the person who created a file can uh, can modify the file any way it wants, right? Because he is the owner of the file, right? So then we have a group, so it can contain multiple users. So all the members of a single, if you assign a write permission to a group, all of the members under that group will have the right permission to that file, right? This is how the group works, and there can also be other permissions in the system. So okay, so what type of permission we are talking about? So it can be read permission, write permission, or execute permission, right? So if we don't have if you only have read permission to a file, you can only read, but you cannot. If you want to try to modify the file, it will show you the permission denied or something like this kind of error. Okay, so if you can see the permissions with this command like ls minus, just doing ls minus l there. So dash here, it means it's just a normal file, not a directory. So the D represents, so if you see D here, that means it's a folder, it's a directory there. And yeah, there can be other things like character devices, block devices. And this block, these things are W, this represents the permissions. R means read and W means write. So they have read or write permission to this file. Then we have the link count. Link count represents it's related to the file system in Linux. How many files under that folder, things like that. And we have the owner of the file, and we have the group. Then the file size, these are the simple metadata, some informations, like last modified information, things like that. Then the file name at last. Okay, so this is the last topic that we will cover today, is the C2 ID programs. So this is important for this session. So we discussed before about the loader. The loader will load your application from your hard disk to memory and run the program, right? So then it becomes an application, like a process running in your machine. So during loading this program, it will actually check for permissions in the file. The loader will check if I am if I logged in as a user A, it will check if user A actually have the permission to execute the file or not, right? So those things are done by the loader, and it's part of the kernel, not like user application. Okay. So a process, for example, a process can have some we know that it has a process ID, right? So there are three more IDs for here. One is the real UID. So real UID of the process that the user who created the file is the real UID. And it can also be, it can be changed only if the running process has EUID is 0. So EUID is effective user ID. So it's for root. So 0 means it's a root user, effective UID. And yeah, so actually the loader actually checks this one. This is the important one, is the effective UID. It checks the effective UID to check those permissions for the process. And another property of this one is that it can be changed to real UID or SUID later, depending on some other criteria too. So we'll actually look into the C2ID programs. So as it says, like the kernel makes a decision whether a process has the privilege by looking at the UID. So this is the important thing. And what does it mean to be a setuid program? So for the setuid program, when it executes, it can elevate its privilege to the owner of the file. For example, if I am a user A and I am running a program that is setuid program, it can go to higher privilege level like root, right? It has this is the but for non setuid programs they cannot do that. Only the setuid programs has this capability to elevate its privilege to a higher privileged user. Okay, so if we want to see some setuid programs, if you go under /bin in your Linux machine, and if you do ls-l, you will see there are some applications that are marked like this or like marked differently. Those are actually the setuid programs because this S bit, this S represents it's a setuid program. The S here, RWS, this denotes it's a setuid program. Some of the examples are here. You can have more like this. Okay, so let's look an example of this one. This is an example code. Okay, so in this code from the main function, we first get a file pointer. We get so this is how you can get the user ID or UID of the program. So this gets the real UID, and this gets the effective UID of the user, right? So if we have a file named flag that we don't have permission to read, but we'll see the real example of this one. But if this program is a setuid program, it can access. We cannot access, but the program can access the flag file. So we can see a real. It's also here. If you go to the website, we have our secret file here. Okay, and we run this one. We do ls. So this one is the file that we are looking into. So this is the setuid program. So we can check that by like doing this. You can see the setuid bit is set for this program. Okay, just do ls-al here. Okay, so the file we want to read is this one, flag, right? But we can see the owner is root here. And if we check who am I, we'll see we are the CTF user, right? So we don't have permission to read the file. So if we try to cat the file, we'll see it says permission denied because we are CTF, but the owner of this file is root, right? So we don't have permission to read that file. But this is a setuid program, right? So as if you see the source code of this one, as I said that it can go to higher privilege levels, right? So if we see the print flag function, it's actually just reading the flag file and just printing out in the std out, right? So if we run the program like this, we will see that this real user ID is CTF. Actually, we are logged in as CTF, right? But the program effective user ID is root. As it's a setuid program, it elevates its privilege to root, right? And the flag file, the owner of this flag file is root, right? So root can write anything to that file, right? So that's why that program can read this file, but we cannot read the file like if we just cat, we cannot read that file because we are running the cat as CTF, right? Not as root. Yeah. Mhm. Yes, dot slash. This is how we run the program. Yes, but this program is a setuid program, so it can go to higher privilege. It can elevate its privilege to root. Right. This is a specialty of the setuid programs, different from normal programs. Normal programs cannot do that. So if the same program was not a setuid program, it cannot read the file because it doesn't have the permission, right? So you can see here, this actually the real user is CTF, but actually the effective one is root because of the SetUID capability, right? So, and it gives you the flag. So this is one thing that this is how we will conduct this session. We will have a set of challenges in the session. We will try to exploit those programs, and our goal is to get the flag. Okay, so here is we did nothing, right? We just ran the program to get the flag, right? But for the later challenges, we need to develop the exploit to get this flag.
So how we can utilize the flag? We need.
Yeah. So after we get the flag, so we can submit it to the platform. So it will mark the challenge for you as a solved challenge. So to do this, you just copy this one from here and go to challenges. The challenge is this one, and we just submit the flag there. So it will show you, mark you for your account, it will mark as solved. Yeah, like just to show you like how something look like for the later one. Okay. Okay, so this is all I had for this week. So for next week, we'll look into binary files, stack layouts, mainly for next week. So that's all from this week. Yeah, if you have any questions, you can ask.
Are there any other challenges we can do this week?
No challenges actually.
There is also a long end, right? To show the difference between.
Yeah, we saw that from the slides actually, but it's not a challenge.
Yeah, but we can discuss that. So,
Okay.
what is crack me one? Crack me one is not overflow, right?
Is crack me one we can try to solve. I cannot not overflow. It's not. We can try to solve. Yeah, we can try to solve ourselves.
Work on one.
Yes, everyone can work on crack me one. I think those are doing bandit too. Oh, you did that before, right? Okay. Okay, so crack me one is okay.
That is why you learned today to crack me one. Sorry, 2D version of 60.
Yeah, for this one, try running this challenge. Crack me one underscore 32. You can try to solve this challenge here. maybe we can give them the source code for Crack Me On for now.
No.
No? No, but otherwise it might be. Okay.
Maybe that group that we saw that brought it down. Yeah, try down the take a look at the main one. Yeah, always. Yeah, so for example, at the beginning, you can. I know how to. More complicated. Those are like, yeah. You can understand. You can make just trying to understand what it may be doing. Ah, okay. That just solving the
Do CD dot dot. Yeah, it'll get to, that might not be what.
Let's do CD. Let's do CD. Yes, yeah, there it is. Yeah. Oh. Delete my screen. So go check this is another program. Yeah, so this is another program. Yes. Now go to the terminal. Okay, yes. So this is the program that we want. No, we don't. This is a program also. You can run the program. Dot slash the program name, and which you can use like the tools we learned like GTB, object of those tools to understand what this is doing. The surface area equals, yeah, I thought 510. 500, okay. Yeah. Here, right? Go straight and then just keep and now and then moving forward. Now check the instruction. It's in that we find yeah, we the instruction on the just do this as this finally there for this will try to no it doesn't audio of this one. You don't do audio of this one. Just do anything. Okay, so it's there, right? So that see there is a compare, right? Yeah, this one is interesting, right? So set a great one there. Copy that this. No, not that one. Just copy that this. Okay. Then continue to the next one. Okay. So I can move the again. So it's there, right? This compile territory with the value ESI. is an instrument like this. We're checking this value at the distance. So you can take what is the value of the I use the sort right here and on the video, but there's try many different periods. Yes, so you need to now this looking for it. I think what you do is so P means it's only giving the no, I try to move on get the value for it. So listen, it's see the value is one, right? So if you go back to the code, there you can see the code. So what happens is that there's a compare, right? Probably it's comparing on the word one way you expect this value is one, right? So it means you see there is a JE instruction next. JE means down, but this tip will fail, right? It will not be good. So it means to lose it. Yes. Yes, value is the one you ask to take. It will go to main plus 48, right? So main plus 48 is 10. Tracks, the tracks are being called no, it will jump easy for it is not very right? Then you move forward 0 to 8, then it will jump to because 195 and do business. Also not the original file. Yeah, take the full industry main plus 95 is here, right? Main plus 95. So it is nothing. See, there is nothing there. Which is mechanical. So like because if that's not more. That means so I have short it might get right. Yes. You already have the data. So if you don't fit the data, people will do that. So then yeah. Now just that was that means is one that's why we don't have a source code yet. When you say hey, it probably will not have a source code, right? This state is to check if you appropriated one parameter or not, right? So now you remember parameter, right? Now your program will jump to 48, right? So now we change okay. Go past obstacle. There are some other obstacles next. So when then we debug from here instructions, do it step by step to debug, like to understand each instruction for the program. Then maybe we can develop a squad. Yeah, just run out of time. Yes. Let's continue the difference of the acquisition. You can check that type ID in provider correct yeah. So maybe just now use just the IP and the phone number. Then I think it's phone number to use some. Okay, now oh yeah, 48. They should go to main plus 48, right? Right, so next. You can do one more. Right? Now, we didn't get to even respond, right? We actually didn't do anything. Now we have to figure out what can we input or how can we exploit it, right?
Like you say, it's companies, the number on term.
Then yes.
Somebody come and do one EX, right? If it's a break point here. So actually,
Yeah, no, we are.
Okay, right? So, some EX, right? I think just so you
They use
so what's equal is the mean, right? Very specific line. So but we can have you only don't have integers. So you can do x by n. So if you say string, you can do the string. Occurred only once. So other lines occur many times. Yeah. You understand what you're doing. Yeah, points to the string, which is right? EX now points to the beginning of so now there are some other code, right? We need to check for n to be, right? So then this string EX pushed to the stack. This only this one here one. Others appear. So unique, for example, never use for so to mean. So you need to the package is from location. So that's yeah, but you can we're not. Right? Give you the you will have everything just on one line, right? In theory, give you the.
Oh, I thought we moved the group table. For the name that is.
Yes.
Yeah.
Yeah. Your main function is calling the adder. So you need to give the parameters to add, right? Yes. Do the other parameters. So for this, for that purpose, you need to push those values in the reverse stack. It's done for the stack. Okay, that's why it's pushing the value. So this the pointer to this page. Now we are going calling so you can guess from what can we guess from these two things?
I'm guessing it's an area of our
So Stellian so we are using Stellian to get the length of this one. Then we are comparing what we are giving. Like if you take those code, see the so that is up there. Can you say this one here? So it's compared here. It's comparing EX and EDI, right? Now check the value of those instances. EX2, right? Because you're doing you can just do P. Because EX, no, just P. Not X by X, P by X. P by X. Yeah, okay. Two, right? two, right? The value is two. And then there is another instruction. EDI, check that out.
刚刚已经看到一半了。
Yes.
可以
P
看我
is 11. Yeah. B is 11. So if you say compare the length of C is equal to 11. If you count,
Oh, yeah, since,
是一个那个
B is 3,
yeah, my argument was.
87, 2, that's the equal, right? How, what do you know about this? It's comparing our input to C. Only put it at least 11, right? Whatever, it should be 11, right?
Let's try to run it with,
Yeah,
that's 11.
yeah, that's fine, yeah. That's any other one, there's any that goes wrong. Yeah. No, we don't need to. That's fine. Yeah. Because we have some, just running it, we don't need to, just run with something, yeah, something even type. A or A or all. Okay. That should go. Yes. Okay, now go continue. You have the data already. Yes, continue. Now, yeah, this is, oh, no, maybe, okay, this is. Yeah, you are, that's fine. Now check the in the values of EX and EN.
两个
Is B. Yes. And EN is B. So that now, right, we pass another check. No, but it's not done. There are some other product. There is more, there do pieces. Do pieces. Yeah, yeah, we can, yes, there are other products. So we can check that. So compare should be interesting to solve it. The compare should be interesting. Right? Might be some, if there is mistake, that means yeah, there is some condition, right? We're trying to pass the condition, but things like right? So we can see the difference here. We need to remember what was the input is all I, right? Something. Now check what is the registers, whether yeah, can be
别写成这样的，我们直接写是扣的，不要写标点符号。
it's nine, right? And other things is eight. This is true, right? Can you open a the start asking you start asking you this is what the Google asking. Yeah. Yeah. Take the-
对，因为这一步得过，过完之后。
Yeah, it is. Yeah, but yeah, they should do it. Then there is a 54, right? 54 is B. So now, yeah, then that's
这可能现在这个内部
yeah, I mean, think you can also take a try to now. Yes, that line is right. You can try to let's go with the goal and also you see like what's everything there. Try to be
These are good.
yeah.
Pure.
Yeah, pure. Very much like inside we are outside here. You want to talk about memory, memory, something like yeah, I do what I that's type we are. This is also kind of niche. I should also take some of my here. It's you know, mind of what I here is
这两个语言呢，就是我们是非常这个说的是。
加一了，就往下一个another big point. This is where the last point that we yeah right before this one right. And then you just right and then to try to cover it. You can see all of that. So for example, you know, but you know it's just now but when you know more about that, it will show up this is the constant in the outside. So what's the value of the outside color?
加一，
Yeah, should it be front of the music?
就是跟
No, no, I will eat. Oh, yeah, I will always like I would like hold you. Say, look, just so what solution to this?
我们不看这个，我在看这个，我是这个，
So you define market.
这个是第一层。
Find that you're here, find every now. I was finding, look at the extension, right? Move something to EA, right? If we want to know what this one does, we will put or yeah, really. So we are in. Is it? We are in. What? Yeah, right. Now check the content in PA.
Maybe both. Well, for you, you took my class, right? So if you're feeling to do that, then you can do that. Otherwise, maybe people can ban it. The next week, maybe we will design something for people who have already in my class or do a lot of systems. Most of it would be what requires one in here. Yes.
We take care of them.
Thank you.
I ran it through of the and I found it after.
Or next.
And then I'm going to put you in. Yeah.
Excellent.
Why? Some short, so. You see, we addition five to into 30 plus one.
And the even
Pointer, plus one is actually the we need to y subtract 4, which
okay, nothing there. There's some error, simply the EDA one. So, or you can do email something very something. Yeah. Examine, not P, examine. Oh, you can see with the P, right? Yeah, do examine, it's like P is external. working usually to this one. Right? Then can you take EX in X for X, X for X, not in the
Yes. Wrong is broken. Wrong is broken. You have the same code. I don't know what I mean. I don't mean you have wrong. Or you send me the It's wrong. I don't need you. I don't.
So now this is that to be the bargain is not the one. But that in the GDP, I like to be
So we see here and either what we noted, and it's comparing some, but we don't know what. Oh, that is the. So, okay, it's compared, one is the EX one, EX one is already solved in I, you know, right? It must, other thing must be in ECH. Other thing must be in ECH. This is the last instruction that you are supposed to. So this might be the.
Wow.
And run the really good program for that. From the program from the already past session, right?
and
Yeah, so run is or I see.
So now we don't have any arguments. Now, they don't tell this, we are the ones here, there's here. Here, what seems to be interesting. Here, and here, that is here, it means that right scales. Here, we want to jump to asking for here is what is, where is the data line? We're gonna jump here. So if it is now equal to 2, which are the key line, so we're gonna jump 3, 9, 6. Right? See, we need the key line, 3, 9,
And it's adding 1 to that.
3, 9,
And then we need a value version of the X. In this compare, we found one value is 9, then is I. I is in your right? Then other value is 4.
3, 9.
Right? And that value comes from ECA. Right? So ECA,
The main function
is the first category. Right?
the first
This would be adding 1, then moving that to 2.
Okay.
So how do we develop the, how do we make pass this step? Yes, yes. But for you're just talking about one character, right?
Okay.
But there are other
Here's
characters.
a 3 point.
What should be the, what should be the formula like for equation?
We try a lot of these, or we could try about them now. That's like competing for characters.
You can try all these. Yeah, just try it. First try elements. Yeah, we get to the
Point, okay, and then it's C is continue, okay, we just don't join. And he wants to.
You can need to go. Can you do this assembly? Yeah. Okay, they will compare.
So,
So we know that it will be D, right? C plus 1 should be.
we wanna reach.
No, this is C plus 1 is D, right? This is C is equal to C, right?
Yeah, twice.
And our input is R. So we can obviously get we can go here.
X over X. to them. There is already a paper, so that is the big, just what we have that point. Just take correct, there is one to be, I think now two, I think it's worse. So no, to take the paper number, I think. This is
Except
seems
over
low.
here.
We don't know that this is.
So this is still here.
It is 3 years, right?
But the golden exhibit is
You know, we're gonna see here, you can see. The side of the fire already is from the obvious. So if, this, yeah, it will just, doing some now. Yeah, it will just this number, then we already got. If this one is not here. Now we check the register of tourist job, doesn't work, we will just excuse this thing. And here we have another job. Three
check
nine.
what
Three nine C.
is married.
Yeah.
You will compare it.
And.
We will not marry.
So we make those changes to just returns. So we need to find a way to. Yeah, get to about it. That can be used. See, right? So if we can't get a, that means we can do like part and keep it back on arguments if we keep different. Anything what? Even the argument continue, yeah, this. See, we are here, here is the things, right? Now check the value again. Yes, and okay, so we better see on the MP out there. Like now we can just try what's inside the library. Now in the two. That's good. Because it's for this area is straight out, so it won't just act here. So it's really nice to use the food of the island. It won't actually I don't think it will jump to its level now. It will jump here. But yeah. So we can just speed. It's a for speed, right? Nine. So what can it be then? It doesn't give us just a good kind of it, or continue to check whether or not they can. I'm seeing a security. What is the saying? Yes, I will. He's setting one. Here we go. See the one is. Yes, is 70. 70 plus 1 is T, right? Okay, it is our telephone now. Okay, it's that means we okay. Yes, I'm one each character, that should be. It's so just to call a function in it's choose that we just adding one each character. So we use we could react. So as GRLEN has one argument. The argument is the choice of the student. We have a mind of the left of it. So at this point we can show that the choice of the student is stored into the AIs. Yes. So what's that string? Maybe we can just check that string. So we can set the breakpoint. We can continue back and say, but here's one time GRLEN. How does here work? Because we can set a breakpoint here. When you run any program with APIs, it will not be a security program at this point. I think this is correct. It will not give you a plan, right? You need to go out of GD, just yeah, run it. Yeah, the first one because we are at 309. Actually, I need to submit the flag, and that's what is this one. Yes. So this is the like the small steps to solve the challenge, right? These ones are easy. If you go along, it will get tougher. Right? And you will learn things here. So if the debugger was stopped before executing the function, so XPRLEN. You understand the process? Yeah, I get that. Yeah, we can use the C. Yeah, so there are other things like stack, we'll do that in the next session. Yeah, so let's just more of that means we'll already or if you want to maybe I will do the I think that's all. You are done.
করে ভাই ওটা কি আপনাদের তাই আপনার নামে কি ওর নামে
আমি এই বিষয়ে কোনো কথা হচ্ছে না আপনার সাথে এই জন্য এটা নিয়ে এখন ডিসকাস না করি
আচ্ছা যেহেতু
যাতে আপনার রিস্ক হবে না
কি করা যাবে
নেক্সট যদি আপনার ধরুন আমি জাইলিং ইনস্টল করছি আমি যদি RMRF দিয়ে করে দিই এটা কি প্রপার ওয়ে
RMRF ও আচ্ছা
ডাইরেক্ট পুরো নাকি উইন্ডোজের মতো আনইনস্টল
না যেটা করতে পারেন কিন্তু ডিপেন্ড করে কেমন ইনস্টল করতে
কারণ হচ্ছে আমি চাচ্ছি যে ও এনভায়রনমেন্ট সব ডিলিট করে দিব
কিছু
তারপরে যা আছে এই যে এখানে একটা ইয়া বলছে
হ্যাঁ আমাকে দেখেন কি বলে
অ্যাপ্লিকেশন Xilinx product on Linux and select applications. Application কোথায়?
টুলটা ওপেন করতে হবে মানে ইনস্টলার একটা দেওয়া আছে যে
Xilinx design tool. আমি দেখছিলাম আনসার কোথায় না আছে